So, hello everyone. My name is David Stanley, and I host the Spiritual Journey on YouTube and um, Universal Comprehension Academy. And I have a very special guest this evening. Um, his name is Lyndsay Harris, and he has a completely novel concept of the flat Earth, which he has come about. Uh, Not through traditional means, but by his own inspiration. So, hello, Lyndsay. How are you?
Hello, David. I'm very good, thank you. Good to be here.
Great. So, a few months back, uh, Shiva Ayadora Ray, was talking to David Weiss, and he suggested that we get 10 flat earthers together, and he would bring 10 scientists to validate an experiment that we could propose to prove flat earth 100%, and he would get that peer reviewed. And so he didn't actually get back. He went silent for a long time, and I got in contact with him, or I got in contact with his organization, and he didn't respond himself, but his CEO of his political party in England contacted me, and he said that I personally should get together a group of flat earthers, and we should come up with an experiment to prove flat earth, and he would do his best to make sure it was carried out. So we did that. We got the group together, and one of the people that responded, thankfully, was Lyndsay Harris with his experiment that proves 100% that the earth is flat. You call it an experiment or an observation. Perhaps you could tell us what that observation or experiment would be, Lyndsay.
Well, I don't know if I'd call it an experiment. If someone did it, it would be, of course, but I haven't done it. But to understand it, you have to understand some facts that no one's been informed of, and that is understanding magnetism properly. All we're taught at school is you take a magnet, and you got a north and south pole at each end, and the field comes out of one end and goes to the other. Well, that's total BS. And they show you the flux with the iron filings, and they show all the filings piled up at the ends. In physics, they tell us, the magnetic field on the Earth is strongest at the poles and weak at the equator. They're failing to tell you that both ends are the same, and the fields are coming out at both ends and going towards the equator. And you're not seeing a build-up of the filings near the equator because it's a very weak field, weak force. So on our Earth, both Arctics are North Poles. They're both the same. They're both high pressure. They're both flipping cold. And they've both got ice. And both fields are rushing towards the tropics to find balance, because that's what magnetism is. They're trying to find an equal state of balance. So let's just work on the heat. You've got cold and that warm in the tropics. So they want to marry. So that's what the field's doing. And in meteorology, they show us this, the field's coming towards each side of the tropics and then diverging away. And this is what the two fields are doing. There's two separate magnetic cycles, one for each hemisphere. They both have a north and a south. So the Arctic has the Arctic is the north, and the South Pole is the tropical boundary of Cancer. And in the south, it's the Antarctic and Capricorn. And magnetism has this a phi ratio. And this is described in many esoteric books, whatever. And that's like Plato's unequal divided line. It's several things. But in the Earth's case, the magnetic field is not always equal. It's always an imbalance. And this imbalance creates the seasonal changes where the southern field comes up and overlays the northern hemisphere and back again. And at a certain point in this overlay, you've got the physica piscis in religion. You've got the oval of the two circles meeting. Well, as they're coming together like this, you're forming the constellations. And then as it comes away again, it's deforming the constellations or changing the constellations because they're always coming in from the east, right? They come in, turn up, oh, look, and they're always changing. It's because this rotation is coming up, marrying into this, overlaying the stars. The southern stars are overlaying the northern stars to create these new constellations. So it's understanding magnetism, the imbalance, and a certain time of the year, which is the sun's and lemma crossover, and the sun crosses over. It's the whole Jesus dying on the cross story, is balance. The Earth's magnetic field is balanced. Okay, so when you understand all that, understand magnetism properly, you get to understand the two fields coming from the Arctics to their tropical boundaries. The respective tropical boundaries drop straight down through the ground, along the ground thou shalt go, because the snake represents the magnetic field, and then up at their opposite Arctics. So anyone flying an airplane, specifically from New Zealand to say, let's say Samoa, which I've done plenty of times, when you cross over that 23.4 degree boundary, Capricorn, you get the turbulence. All the pilots know this. You got this up and down flow, coming up through the center, like up through the equator, the down force going down to the sides of the tropical boundaries. So anybody, I think, can get in an aeroplane with an old dip compass. That's the vertical compass with the needle that can do a 360. You'll start at either Arctic. Depends on which way it's magnetized. The needle's going to be pointing up, either up or down. And as you move closer towards, let's say you start at the Antarctic, the closer you get to the Tropic of Capricorn, that needle's going to start going like this. And when you get to the Tropic of Capricorn or thereabouts, it's going to go complete revolution. It's going to curve like this. Where if you start from the Arctic, it's going to be pointing up or down, and then come level, and then dip the opposite when it gets to the South Pole, because the tropical boundaries are the South Poles of our Earth. North to south, north to south. They're doing this rotation all the time. You see it in the stars. In the sun cycle, that's the positive field. The sky, if you can imagine, like if you're in the southern hemisphere, you're seeing the sun come up. We don't see it come up. You can see it coming from the east, but more in the summer months, you get a longer day. You get the sun coming more southeast. So you understand, you know that it's all coming out of the south, and in the north, it's opposite. In their summer season, it comes more northeast. It's actually coming out from the center north, spiraling out like this, right? Well, in the night sky, it's a negative, so you'll see the Milky Way curving the opposite direction. And this is where you create the interlace on the torus field around the Earth, which the ancients called the net. So anyway, that's if someone want to do that experiment, you just get in a plane. You might want to use different altitudes though, because the magnetic field, it's quite high. It comes over the Earth, and then drop straight down the boundaries of the tropics. So you might want to test several altitudes to get the strength, the downward strength. So exactly how it works, I'm not too sure, but you'll find it's you're not going to get much at the equator. So it'll be out there. It'll be the negative force out on the boundaries of the tropical zones. And we know the dip compass dips at both Arctics. So it's obviously both the same. Your compass, any compass, I think any compass, a dive compass, if I took this into the northern hemisphere, my north would be pointing south. So it works all right in my hemisphere, the southern hemisphere. I remember when I went to Egypt, and after a long flight and that, and different diet and drinking flipping bottled water, you don't think too good. I'm there, and the Egyptologist is telling us, the door entryway to the Great Pyramids on the south side. What was he saying? I'm standing at whatever he said. I'm standing at the compass, thinking, what the? I'm thinking, shit, am I going mad, or is this guy an idiot, or what? It wasn't until I got home, weeks later, I realized, oh, flip, I had the northern hemisphere compass. It was the opposite to everything he was saying. Stupid me. But anyway, that's how it goes. That's if you understand magnetism. There you go.
I think that alone is quite a revelation to a lot of people, that there are two different compasses, one for the south and one for the north. And you've obviously got both of them. Now, if you were to do the experiment yourself, how would you do it?
You don't need two compasses. Well, no, you need one of the vertical dip compasses, and you just fly in the airplane holding it and watch the needle go down as you move towards the tropics from either side,
And
either hemisphere.
you mentioned 33 degrees.
360 degrees. It's just like these compasses here, but they're built vertically.
Right, but where that would happen on Earth, the 33-degree mark.
Well,
Latitude.
what?
The latitude.
No, you start in Invercargill if you wanted to, or anywhere in New Zealand. Auckland's about 36 point something degrees south. Just get in your plane and fly direct north. We'll go to Samoa, and as you go flying towards Samoa, you watch the needle go horizontal. It'll sort of be on your 36-degree angle, but it'll start going like this. And then when you get to the tropics, it should point straight down. It's like a clock. You don't need it's just the one dip compass will do the whole experiment, either hemisphere, doesn't matter. But when you're in the if you've got a northern hemisphere compass, you can use that too. But you'll see it start tilting. But if you're traveling, you don't need two different compasses. You just need to understand it will flip opposite as you cross the tropics. So this is why they make us two different compasses. I think there's about 5 compasses they make, but there's specifically one for each hemisphere because the needle's at the other end. It's magnetized the other way around. They just write, it's the same thing, but they just print the north on the south end and vice versa. That's all it is. Because both Arctics are North Poles.
Yeah. Now this dip at the tropics, would you expect this if the Earth was a planet, if it was a ball?
No, because they're teaching you that the magnetic field comes out of the south and goes all the way over their ball and into their north. That's 100% lie. They know that. They know it's a lie. And the funny thing is, I've been showing this for years, and then someone sent me Nigel Cheese's video I'd seen years before, and I ran over it again to see if I could pick. I'm always learning and thinking of things, so I'm always finding something new in people's videos if I go back and watch them again. And this particular time, I realized, oh my God, he just showed us what I've been showing, how the field comes from the Arctics and goes into the tropical sides. Like, I'll draw you a picture. You see that?
Yeah, definitely. Yeah.
He drew the globe. I'll tell you what, with your globe, the magnetic field doesn't go around like that, he said. It goes like this. And it goes like this. So he went and showed it. But whether he wanted to mention that the Earth is actually flat or not, but people just go off their lid when someone starts talking about flat Earth. So people don't want to lose their following by mentioning flat Earth. But he's done it there. He's drawn it there using the globe, and there's no way it can work on a globe if you go deeper into all the physics to make their globe theory work. It just doesn't work. So once you realize the magnetic field doesn't go all the way around to there, you know their whole model is a joke. It's all a lie. It's all fabricated, because they're trying to tell you this is south, this is north. But then they tell you the north is actually the South Pole because that field wants to get to there, whatever. But anyway, there's your north, there's your south, there's your south, there's your north. North, south, north, south, north, south, north, south. And the sky's forever going like this on a meridian, like every man is on a meridian. That's his fixed cycle. Like if he fixed a camera on a tripod and watches star trails, that's it. That's all he gets. But
could you lift up that board a little bit? Yeah, just like, well, yeah, you can put it down about 6 inches.
I'll draw another one. Let's draw can you see that?
Yeah.
Let's say that's the flat Earth. There's
Okay,
your latitude.
you need to lift that board up about 3 inches. Okay, that's fine. Yeah.
There's your flat Earth. There's your latitudes. There's your so it's the equator. The field comes around like this, and out of the north, let's say that's Capricorn. Then you've got Cancer here. The field comes out of the north and comes around like this. So the field's always continuously going around like that. It's the spider web in celestial navigation. The stars are doing that sort of pattern. Out of the south, it's coming around like this. This is infinite. You actually create your own. We have our own sun and a lemma, like this in the south. They have theirs from the north, like that. There's the equator. So in the south, it's like that. And this is the sun's cycle represented in Christ. Christ washing his feet on the banks of the Jordan, or washing the disciples' feet. It's all about the tropical boundaries, the river, the Nile, the Jordan, whatever you want to call it. It's the Bible's a book of physics, astrophysics, and all the other ancient books are astro mythology. Basically, all the mythological stories are all about the physics of the flat Earth system. So it's all described, and this is what I do in my videos. So the magnetic field comes out of here, goes to there, and then drops straight down to the ground. So then you get a side elevation. So if you put a cut through there and look through this way, there's Capricorn and Cancer. Capricorn and Cancer. There's the north, Arctic. Should call them Arctics, not north and south. Arctic. The field comes up here, straight down along the ground thou shalt go, then up and out here. It comes up out here, down here, along the ground, and then back up here. And that's the cycle. That's the infinity symbol that's been around for millions of years.
Right, and it does it on the other side, on the other half.
Same thing, comes out of there, goes around like that. This is that symbol you've always seen.
An dilemma.
And all the ancient cultures always have these drawn into their images somewhere. You know, it's not quite the analemma, that's the infinity symbol. The analemma is the unequal. And this is why you see we've got the tropical gap, right? Yeah. And this, look, you look at it, it's the same as the human brain, the north and south, left and right hemispheres of the brain. We see our sun here. That's where the pineal gland is in our head. But the real sun is back here in creation here. The Milky Way comes over like this. So we get an image in our light spectrum. This is singularity back at creation. And the toroidal field is blown out and made our world dual. So the sun becomes split, male and female. So we see a moon and a sun. But the sun is male and female back at singularity. What I was going to say, magnetic field. That's right. So we get the two night skies like this. There's a gap. Orion's belt comes through here. That's the celestial tropical gap. Southern hemisphere, northern hemisphere. And where was I going with that? Oh, okay. So you would imagine this gap here is dead center here. And it is. But this is our realm, perceived as the physical realm. This is creation. So everything is relative to the observer. So you've got to understand that this might seem equal to us, but in reality it's unequal. So the physics has the ecliptic plane back here. It's not centralized. So you look up at the night sky and you see this rotation like this. That is the center. That's where Orion's belt comes through. But they go and draw the ecliptic plane over here. Because this is the true system. It's unequal. So they draw the ecliptic plane over here. That confuses everybody. If you're into astrophysics, want to look at the night sky, just ignore what they're showing. That is the dividing line between the northern hemisphere and the southern hemisphere. Right there, where Orion's belt comes through, the center. So it's understanding this discrepancy between the creation and our realm. So you always see the Physica Piscis like this, two equal circles, right? But in reality, the southern hemisphere is like this. It's a nearly a 3-to-2 ratio. So it's a 1.618 ratio, and it all goes back to magnetism. And people just don't know enough about magnetism. That's the problem.
They don't teach you that in school.
No, they don't.
You do have some videos. I've seen you show some videos where a guy is actually testing the dip compass and he's on a ship. Yes?
Yeah, well, I could work on a ship. You don't have to be an aeroplane. They used to use them all the time in the ships.
Yeah. Do you remember that video you showed?
I do now. That was a young guy. Yeah, that was a
Yeah,
really good video. Yeah.
yeah. If I can put that video under this video, yeah, a link for that video. If you can send me that, I've got it somewhere, but perhaps you can find it easier.
Oh, I don't keep track of my videos.
Okay,
You'd find it
okay,
easier than me,
okay,
probably.
okay. I'll try and find it myself. Yeah, I've got it somewhere. Um,
Yeah.
but you send me links for everything you want under this video to your videos. Yeah, because what you've given, what you've just uh, been through is like a sample. Now I could understand everything you were saying, but other people might just find it a bit more difficult. Yeah, because I mean I've put over 100 hours into studying your concept, and for me, it's the next level of flat Earth, the magnetism. Yeah.
Well, to know that to understand flat Earth, you need to understand magnetism. That's why a lot of guys have been drawn to Ken Wheeler because he explains a lot of it, but he doesn't sort of relate it to the flat Earth model. He shies away from that, but he must know the Earth's flat for sure. He
He
describes it.
he has admitted it on one video. Yeah, I've seen him talk about it. You've not seen that one?
Not is that one with the Santos Benassi in them or
Oh,
no?
I can't remember who it was, but I saw him saying, yeah, the Earth's flat, but he doesn't want to go into that because I mean that would
Yeah,
prejudice
I think
his.
I might have seen that, but then he goes on in other videos to try and laugh, it's not flat, blah, blah, blah. So, no,
Yeah.
it's flat, all right. And I sat down the other day, just like I sat down during COVID. I thought, well, I've got plenty of time on my hands. I'm going to sit down and figure out the physics of our flat Earth. If I'm going to argue with people, I need to know how it works. So within a few days, I'd figured it all out. And I've just been expanding on that. I didn't sort of I had stuff in my head and I try to explain it to people, but when I go back and look at the videos, I think, what the hell? But anyway, I've since figured out everything. And so yes, a couple of days ago, I sat down and thought, well, I'm gonna figure out whether just this here, man's arc of horizon, can give me the circumference of the Earth, and it does. So it makes people like Aristophanes and the likes of Simon Dan's just done an experiment. I'll link that video. When I put this video up, I'm going to link Simon Dan's video to it and show them how they lie. They're just a bunch of flipping idiots because you didn't need all that garbage. It's all here by just understanding a little bit of celestial navigation, Pythagorean geometry, the 3-4-5 triangle, and that's about it. And it gave me the circumference of the Earth, and I think I've got the accurate measurement compared to them. I came up with 24,937 miles, and they have 24,901. Now this can't be wrong what I've got, so I reckon I'd go with my measurement. So I'll be putting that video up soon, but that's going through my Patreon first, and then I'll get onto YouTube sooner or later because it's quite an interesting video. Yeah. So where were we going with that?
Right. Well, this is part one. We're going to finish here. I'm going to send you another link. Yes, and we can carry on with part two. But this is going
Okay.
to finish in just a few moments, and so we might as well say goodbye here. That's part one, and part two we'll go into it a bit more.
Okay. See you
So
soon.
yeah,
Cheers.
cheers.